In this video, we're going to be learning about interval notation and combining like terms. So hopefully a lot of this is a review. So make sure you take some time to do this warm-up. And now let's talk about interval notation. So if we have an open circle on a number line or a closed circle, they mean two different things. So an open circle means something is not included in the interval. So this might be something that's like a less than or greater than. So we don't actually want to include it. We just want to go near it. And a closed circle is included in the interval. So this will be something like a less than or equal to or greater than or equal to. We have the same thing with parentheses and brackets. So here's our parentheses, here's our brackets. A parentheses, those are not included in the interval. So again, for less than or greater than, and brackets are included in the interval. So for less than or equal to or greater than or equal to. So if I'm talking about -1 is less than x is less than 3, I have a -1 to 3. And both of these are using parentheses because they're not actually included. We're just going greater than or less than. We're not letting it equal that. So on a graph, if I go from -1 to 3, I'm going to use open circles, and I'm going to just shade the area in between. If I have -1 is less than or equal to x is less than or equal to 3, I'm going to include brackets because now it can be -1 or 3. So for my graph, for -1 and 3, it can be those. So I'm going to shade them in because it can be equal and then shade in between. For -1 is less than x is less than or equal to 3. Now I'm including the 3 but not the 1 because this doesn't have an equal sign, this does. So for -1 to 3, I'm not including 3, but I'm including I'm not including -1, I'm including 3, and then I'm going to include everything in between. For -1 is less than or equal to x is less than 3, I'm not including 3, I'm including -1. So this is the opposite of the one we just did. And these problems really just helps to have like a highlighter or something, or it could always shade. Now, this says x is less than 3. So what I'm going to do first is actually make my number line. I want everything less than 3, so I'm going to use an open circle, and I'm going to shade everything to the left. Now what I like to do is put a negative infinity sign over here at the end of this arrow and an infinity sign to the right. When I write my interval, make sure you write it left to right in terms of numbers, so smaller to bigger. So starting on the left, the first thing I see is a negative infinity. Moving towards the right, I see a 3. 3 is not included. What about negative infinity? So for negative infinity and infinity, we always use parentheses because you can't really contain them. So use parentheses for negative infinity and infinity always. Let's try another. I have x is less than or equal to 3. So on my number line, I'm going to color in 3, and I'm going to shade everything that's less than it. Again, if I put my negative infinity to infinity when I read left to right, I go from negative infinity to 3, and now I'm including 3. Now let's try it for 1, or -1. So I'm at -1, and it says it's greater than. So I'm going to put an open circle, x is greater than, so I'm going to shade everything to the left. Now if I put my negative infinity to infinity and read left to right, the first thing I hit is a -1, then I hit infinity. I can't contain infinity, and I don't want to include -1. Last, I'm going to start with my -1. This time it's greater than or equal to, so I'm going to include it. And now when I shade everything greater than it. The first thing I hit is a -1, then I hit infinity left to right, and now I want to include -1. Next up, we have combining like terms. So we're going to switch gears a little bit. So our order of operations, remember, is PEMDAS. And when I do this, I like to write multiplication and division and then addition and subtraction on the same level as each other, because it's whichever comes first, left to right. So let's try to evaluate each expression. The first thing I'll do is parentheses. So 5 minus 3 is 2 cubed plus 2 times 6. Now I'll do exponents. So 2 cubed is 8 plus 2 times 6. Then I'll do multiplication and division. So next up is a 2 times 6. So 8 plus 12. And finally, I'll just add those together. In my next example, I'm going to look for parentheses first. So this 4 minus 2. And now I'm going to do multiplication and division left to right. So 2 times 5 is 10 times 2. 10 times 2 is 20. So I get 24. Let's try this again. Parentheses are first. 6 times 2 is 12. Divided by 2 times 4 is 8 minus 2. So I get 12 divided by 8 minus 2 is 6. 12 divided by 6 is 2. Lastly, I have 4 times 3 plus 10 minus 1 divided by 3. Parentheses first. Now multiplication and division left to right. So you're going to scan this, do this first. So 12 plus 9 divided by 3 is 3. So 12 plus 3 is 15. Now let's go over like terms. So some examples of like terms, we have 5 and 6, x and 4x, 2x squared and x squared. So as long as we have the same variable like this or the same exponent, it doesn't matter what the coefficient is. So 2 and 5, they can be different. We can combine like terms by just adding the number in front of the variable and keeping the exponent. So an example of this, I have 3x squareds plus 4x squareds, so I get 7 of them. So this x squared is my like term, so it might help you to box it, and then say I have 3 boxes plus 4 boxes, so I have 7 boxes. So in this first example, 5b minus 8b, I have 5 of something, I'm subtracting 8 of them, so I'm left with 3 of them. My second example, I have 2 x's, and I'm subtracting 6 x's, so I have minus 4 x's. Now let's get a little bit more complicated. Negative 2m minus 9m times 1 minus m. My first step is to distribute. You always want to distribute first. So I have negative 2m. Negative 9m plus times 1 is negative 9m. Negative 9m times negative m is positive 9m squared. So just in case you forget, you might want to write down, remember, x times x gives me x squared. So now let's continue on. We get negative 2m minus 9m is a negative 11m plus 9m squared. We can't combine these last two terms because they're not like terms. One has an exponent of 2 and one really has an exponent of 1 right there. Next up, we are going to distribute. 2x times 8x is 16x squared. 2x times 10 is 20x minus 10x squared. Now combine like terms. 6x squared plus 20x. Next up, I see parentheses, so I'm going to distribute here and I'm going to distribute here. So I get negative 5 minus 50p plus 20 minus 30p. Combine like terms. Negative 50p minus 30p is negative 80p. Negative 5 plus 20 is plus 15. Once again, I have parentheses. I'm going to distribute. 7 times negative 1, negative 7. 7 times negative 2n, negative 14n. Negative 5 times 7n, negative 35n. Negative 5 times negative 3 is plus 15. And now just combine your like terms to get negative 49n plus 8. Next up, this one is tricky because people always make a mistake on it. So if you see a negative sign before parentheses, you want to put a 1 because this is really like a negative 1, and you will remember to distribute that negative sign to both terms. A lot of people forget to distribute the negative sign to the second term. So we get 5 minus 8k cubed minus 5 minus 7k cubed. Now combine like terms. Negative 8k cubed minus 7k cubed is negative 15k cubed, and 5 minus 5 is 0. Next up, for this one, since it's just a plus 1, we're just distributing a 1, which doesn't actually change anything, so let's just drop the parentheses. And now we can combine like terms. All right, we've got a few more to go. This next one, and since it's a minus sign, let's put a minus 1 so we remember to distribute the minus 1 to everything. So we get a minus 5x cubed plus 5x plus 2. So it changes the sign of everything inside the parentheses. And now let's try to combine some like terms. So we get negative 10x cubed plus 8x squared plus 5x plus 3. This next problem looks really similar, but since we have a plus 1 right here, when we distribute it, it doesn't really do anything. So let's just drop parentheses. And now let's combine like terms. So I see a negative k cubed and a 7k cubed. Those are going to cancel. Just 6k and a k. So I end up with 4k squared plus 7k plus 2. All right, one more. We're almost there. Oh, I lied. 2 more. Surprise. We have a minus 1, so let's remember to distribute that. So we get minus 6 plus 6b plus 2b cubed plus 4b cubed plus 4. Now we're going to combine like terms. So we'll get 6b cubed plus 10b minus 10. All right, one more. We can do it. This time we're lucky because there's all addition in between, so we can really just drop the parentheses. And combine like terms. Those are going to cancel out. And we end with negative m cubed plus m squared plus 13.